All right, welcome back. So we're gonna verify, is this a right triangle? If it is, this would be the right angle. So I'm gonna make that my C, right? This is gonna be C, and then either one of these can be A and B. So 12 squared plus 9 squared, and we're checking, is that equal to 15 squared? So we have 144 plus 81, and we're asking, is this equal to 225? So I would add these together. I get a 5, that's a 2, and that would be a 2. Is 225 equal to 225? Yes. So we'll say yes, this is a right triangle. All right, the next one, we're verifying if this is a right triangle. If it is, this will be my C, and then these can be my A and B in either order. So I'm going to check it out. I'm going to plug it into the Pythagorean theorem. 10 squared plus, now when you square something that has a radical, you need to square the entire quantity. So I'm putting parentheses around it so I don't forget to square the entire thing. And then is that equal to 16 squared? So this is 100. Now when we square this, we're going to distribute our square, remember, to both, not distribute, but we're going to multiply each of our exponents, right, by the exponent of 2. And so this is going to be 2 to the second times square root 39 squared. And then that is supposed to equal 256. So that would be 100 plus 2 squared is 4. A square and a square root cancel out, so we're left with 39. And we're asking, does that equal 256? And so we're going to verify that by multiplying. I'm going to get my calculator out so I don't make any errors. So 4 times 39, although 4 times 40 is 160, and so it's 136, but, or sorry, 156, but all right, so there it is, 100 plus 156, is that equal to 256? Yes, 256 is equal to 256. So check, this is a right triangle. All right, next one. It says, to verify again, so 9 squared, again, this would be our hypotenuse if it's a right triangle. So that's C, and then here's A and B. So 9 squared plus square root 115 squared is equal to 11 squared. You notice that this doesn't have a coefficient, so I'm not putting parentheses, but you can if you want to. 9 squared is 81, plus a square and a square root cancel out. We have 115, and that's supposed to equal 121, 11 squared. And 81 plus 115 is 196. And they're asking, does that equal 121? Again, remember we were checking. No, it's not equal, so not a right triangle. All right, our last one, we're going to square some decimals. So I'm definitely going to use my calculator for this one. If this is a right triangle, then this would be C, and A and B can be right, these two. So 39 squared plus 32.5 squared, does that equal 48.5 squared? I don't know 39 squared. I'm going to use my calculator. 39 squared is 1521 plus 32.5 squared is 1056.25. And does that equal 48.5 squared, which is 2352.25? 2352.25. And then I'll add these two and see if I get that same answer. 1521 plus 1056.25, which is 2577.25. Does that equal 2352.25? No, it does not. So this is not a right triangle. All right. So flipping it over, we see that Pythagorean triples are 3 positive integers that satisfy the Pythagorean theorem. So just to remind you, integers have to be whole numbers. They cannot be fractions or decimals. So it's not that you can't have a fraction or decimal that would make a Pythagorean, a right triangle. It's that a Pythagorean triple has to be an integer, right? And there has to be 3 of them. All right, so it says, use the following exercise to fully understand what makes a Pythagorean triple. All right, use the Pythagorean theorem to find the missing dimension for each right triangle, then complete the chart. All right, so we're going to find, for A, we're going to find this missing side, C. And so the short leg would be 3. The long leg would be 4, right? And the hypotenuse, well, we have to find it. And so we're looking for 3 squared plus 4 squared equals C squared. And so that would be 9 plus 16 equals C squared. So 25 is equal to C squared. Square root both sides, and we get C equals 5. So the hypotenuse is 5. This is a Pythagorean triple because we have an integer, another integer, and another integer that satisfy the Pythagorean theorem. Here we're looking for either A or B. I'll call it A. So we're going to have A squared plus 5 squared equals 13 squared. A squared plus 25 equals 169. I'll subtract 25 from each side. A squared equals 144. And then I would square root both sides. A equals 12. And so my legs would be 12, 5, 12, and 13. Again, this is a Pythagorean triple because it satisfies the Pythagorean theorem, and these are all integer values. All right, the next one, we'll call this one A. And so I have A squared plus 7 squared is equal to 25 squared. So A squared plus 49 is equal to 625. And to save myself some arithmetic, 625 minus 49 is 576. So A squared equals 576, and then I would square root both sides. I don't know the square root of 576, so I'm going to use my calculator. Square root 576 is 24. So A equals 24. So we would have the shortest leg is 7, the longer leg is 24, and then the hypotenuse was 25. Again, these are Pythagorean triples. I would like you to try to verify the next 3. So you should pause the video here. I'm going to pause it as well, and I'll see you on the next video.